Hello, welcome back to the second part of our topic of discussion. That is, in this video we will be discussing about how to traverse through a linked list. First video we have already discussed about how to create a linked list. Hope you all have watched that. If not, please go back and watch the process of creation of a linked list. Now in this video we will learn how to traverse through a linked list. Step by step explanation is given below, and we also have the algorithm and the source code with us. In order to traverse through a linked list, we require a pointer variable which will help us to point to each and every node of our linked list. That pointer variable which we will be using here is the ptr. Firstly, we will assign ptr with the value of root in order to get access to the first node of the linked list. So we are writing ptr equals to root. Now if I write link of ptr, what does that mean? Link of ptr means the link part of the node which is being pointed out by ptr. From this diagram, it is clear enough to understand that ptr is pointing to the first node. So the link part of the first node, that is this part, is consisting of the address of the next node of the linked list. That is, link of ptr contains address of second node. Now if I write ptr equals to link of ptr, then what can we say? Then we can say ptr equals to contains address of second node. So ptr is now having the address of the second node. So as soon as we write ptr equals to link of ptr, it is pointing to the next node which is present just after the node which is presently being pointed out by ptr. So now after we have said ptr equals to link of ptr, it means ptr is now pointing to second node. You just see, I have marked over here like this. If again I write ptr equals to link of ptr, that means what? Presently ptr is pointing to this node, so the link part of this node is pointing to the third node, so the ptr is now pointing to the third node. Okay, so only this statement, if written within a loop with suitable conditions, will help us to traverse through the entire linked list, because ptr equals to link of ptr simply means that the pointer will point to the next node which appears just after the node which the ptr is presently pointing. Once again, if this is ptr node, or if this is the node pointed out by the ptr, then ptr equals to ptr of link, this one will change the pointer to point from this node to the next node. And again if we write the same statement, that is this statement, again the ptr will change from pointing from the present node to the next node. In this way we can traverse to the entire linked list if we write this statement within a for loop with suitable conditions. Now let's see. Now suppose we want to display a linked list, that is each and every node of the linked list needs to be displayed. In that case what happens? We have to traverse through the entire linked list to print each and every node of the linked list. So we follow the procedure of traversal in case of display procedure. See, first I have assigned ptr with the value of root. Then I have said that repeat the substep until and unless the link part of the node pointed out by the ptr is equals to null. Now if I say this, what does that mean? I am saying continue the loop until and unless the node pointed out by the PTR consists of a null pointer. That is, until and unless I reach the last node, please continue the loop. So the loop will continue until and unless we reach the last node. So as it is a display function, then what will it do? It will print the information part of the nodes, which will be written within the loop used by us, and we will update the pointer as PTR equals to link of PTR. You know why we have to update the PTR in this manner. Now what happens? Inside the loop we have printed the values of the nodes up till the second last node, because when the node is pointing to the null, that is when we are reaching the last node, then we are stopping to enter into the while loop. Our while loop will not execute because we have given such condition. So after the while loop we will print the information part of the last node. See, after the while loop I have printed the info part of the last node, which is pointed out by PTR. With this we come to an end of algorithm of creation and traversal, that is display. Now we will see the source codes. Let's see, I'm opening my Fedora 21. Let's see, sorry. Now we will start with the source code of creation and display. Let's see, I have already designed a program in that manner. vi creation.c. So see, this is the source code. This is the structure of the node consisting of information and the link. And you see, this is the creation function. Create, this is the item. I have already explained this in our algorithm. If y'all forgotten, then please go back to my first lecture, first part of our topic of discussion, and see how this function is working. Then come to display. See, this is display. I have just now explained how this display is working, and this is the main from where our execution will start. Just see this. Enter the new node value, then the user will enter the value of the new node, and that should be passed as parameter, okay, in function create. Then we will ask the user that if he wants to continue to insert new nodes, then he should press 1, otherwise should press 0. If 1, then you see this condition is satisfied, again it will enter and another node is created. And if it is 0, this condition is violated, and so we will come out of the loop and we will print the final linked list using the function display. Now let's run it and see. Okay, just see, I will use GCC compiler, GCC creation.c, let PBR object. Okay, let's see, enter the value of new node. So let it be 2. Do you want to continue? Yes, I want to continue. 1, let it be 5. Yes, I want to continue. Let it be 9. Now I don't want to continue. I am satisfied with a linked list with 3 nodes. Let's see. 0. The finally created linked list is 259. You just see I have entered 259 and it is showing this. So our program has successfully ran. Okay. Now let's see another program, traversal.c, which will help us to count the number of nodes in a linked list. So creation is clear to you, how to create a linked list. Deletion is also clear. And in count function, what we will do is we will just count the number of nodes. Okay, and that counting will be done within the while loop. It is using the same concept of traversal, only in case of in case of display, we are over here printing the node values. Over here we will count the number of nodes inside the while loop. Okay, now let's see. This is the main, this is our program. From main it will get executed. Once more I'm showing you the source code. This and display and main. Okay, now let's run this. Okay, let's clear this first. Okay, now let's run this. GCC traversal.c. Okay, new node 2 1 4 1 6 1 9. Now I don't want to continue. So see, the created final linked list is 2469 as I have already entered. And how many nodes I have entered? 4. So it is showing the number of nodes in the linked list is 4. With this I come to the end of this video. So please, if you liked my video, please like it, please share it, and don't forget to subscribe. And thank you for watching the video. For more updates, please subscribe to my channel. Thank you. Bye bye. Keep going, keep updated.